Ever pondered why the Pythagoras theorem holds such a significant place in the world of mathematics? Let's unravel the mystery together. Pythagoras' theorem, named after the Greek philosopher and mathematician Pythagoras, states that in a right-angled triangle, the square of the hypotenuse is equal to the sum of the squares of the other two sides. Now, what is a hypotenuse, you may ask? Quite simply, it's the longest side of a right-angled triangle, the one opposite the right angle. To illustrate, imagine a right-angled triangle. Label the hypotenuse as C and the other two sides as A and B. According to Pythagoras' theorem, the square of C is equal to the square of A plus the square of B. In mathematical terms, this translates to C squared equals a squared plus B squared. But how can we prove this theorem? Well, there are numerous proofs. One of the simplest involves drawing a square with side length A plus B and then dividing it into two different ways. First, as one square of side C and two rectangles of sides A and B. Second, as four triangles with sides A, B, C, and one square of side A and another square of side B. By comparing areas in these two divisions, we can prove that C squared equals a squared plus B squared. The beauty of Pythagoras' theorem lies not only in its simplicity, but also in its wide-ranging applications. It's used in various fields, including engineering, architecture, physics, computer science, and even in GPS technology to calculate distances. Imagine a scenario where an engineer needs to determine the length of a cable to be laid diagonally across a rectangular room. By knowing the width and length of the room, the engineer can use Pythagoras' theorem to calculate the length of the cable. Or consider the GPS in your car. It uses Pythagoras' theorem to calculate the shortest distance between 2 points on a map, making your journey more efficient. To summarize, Pythagoras' theorem, C squared equals a squared plus B squared, is a fundamental principle in geometry. Its proof, involving the comparison of areas, demonstrates the theorem's validity. Examples from engineering to GPS technology highlight its practical applications. So the next time you see a right-angled triangle, remember Pythagoras and his profound theorem that continues to shape the world around us.